We should be live now. Okay. Okay, good evening, Facebookers, those in Facebook land, YouTube land. Welcome to another evening on Say It Loud with Eve, another discussion. And tonight we're having our part two of the discussion on COVID, the vaccine, the variants, the vaccine, the variants, and the viruses. Maybe I said that wrong. But welcome to another episode on Say It Loud tonight. Thanks for joining us. Thanks for tuning in. Please remember to share this video so that others will know that we're here, we're live, and we're ready to go. A lot of it I have developed since our last discussion on the topic, and we're going to try and cover as much as we can tonight. Today in the UK, we've seen over 126,000 deaths as a result of COVID. We've also recently seen over 31.7 million people receiving their first vaccination. And thank God, there's a gradual decline in the death rate, the number of people being hospitalized due to COVID. Also in the US, we've seen recently, I think up to yesterday, over 556,000, deaths. The death toll has reached now. And luckily, they are doing well with vaccinating, even though it's a small percentage, 19.4%. Over 169 million people receiving at least one vaccination for the COVID disease. But in spite of all of these, we still have concerns, looming about the virus, about the variants, the vaccines. We've seen gradual increase in the uptake among minority ethnic groups where the vaccine is concerned. But we still have questions. Does this mean that there's no more confidence in the vaccine, or has the uncertainty shifted to supply? Is hesitancy still an issue within this group or among people in general? And how is the government addressing this at the moment? Stay tuned tonight. We will be bringing you some light and closure to some of these questions in our discussion tonight. I just want to go ahead and introduce our guests. Firstly, we had him on the program last time, Professor Wilmore Webley. He is an associate professor of microbiology and the director of pre-med and pre-health advising at the University of Massachusetts Amherst in the USA. Professor Webley's work in health has been heavily research focused, mainly on infectious diseases and disease mechanisms and the role of specific infections in chronic diseases. He's pioneered work in chlamydia vaccine development and the role of pathogenic microbes in asthma initiation and exacerbation at the Webley Lab. Professor Webley was recognized in a national media coverage for organizing and moderating a panel on the 2014 Ebola outbreak. He's made multiple presentations to various groups on the coronavirus pandemic, including radio shows. He's been on Facebook Live several times, TV shows, YouTube, and several Facebook Live events. He's the recipient of several awards for his work and role in research and teaching. He's a publishing author of several medical books on infectious diseases and research articles. Professor Webley currently guides and mentors students, including medical, dental, physician assistants, in order to enhance their competitiveness for admission to professional health programs. His work has been published in reputable international journals. He's made significant contribution to the field of microbiology, vaccinology, allergy, immunology. His community roles include board member for Big Brother and Sister of Hampshire County and board chair for Springfield Seventh-day Adventist Junior Academy. Our second guest tonight is Dr. Garrick Wilson. Dr. Wilson oversees convergent science training at Imperial College London and the Institute of Cancer Research. Convergent science is the amalgamation of biological, chemical engineering, natural and physical sciences to develop new methodologies and technologies for the prevention, detection, and treatment of cancers. Dr. Garrick is also an honorary vascular scientist at the National Heart and Lung Institute with an interest in blood vessel dysfunction that leads to strokes and coronary heart disease. He received core training in infectious diseases, including molecular virology and viral pathogenesis from the University of Birmingham and Public Health England. Dr. Wilson is a noted publisher of several scholarly articles describing various aspects of human diseases, including viral infection and transmission. He's also a minister, a pastor in training at Chrisma Christian Center in London, with a portfolio in ministry operations. He also runs a mentoring initiative which promotes educational and entrepreneurial aspirations among young Black men. And I just want to say, Drs. Garrick and Professor Webley, welcome to tonight's discussion. And again, thank you both for joining me for what promises to be a very informative and educational discussion tonight. And I was hoping and praying that Dr. Garrick would not go AWOL on us, but he's made the sacrifice and he's here with us tonight. For those who's been asking, he's here with us tonight. Right, so last time we had a very interactive and informative discussion about the 3 V's, and we've heard some of the fears and concerns, people were still having about these. And we also heard some misinformations I think they're still floating on social media, in WhatsApp groups, etc., which makes clear why conversations like these are so important. And more importantly, to hear from experts like yourselves, to explain and provide factual information and to clarify some of these false information that's out there. So thank you for joining us. I want to say to the public, for those who would like to join us on YouTube Live, we're also live on YouTube. You can go over to the YouTube channel and watch. And please post your questions and comments in the comment box and we'll take it from there. I've had a few questions from our last discussion, so I'm just gonna crack on with those and we'll pick up the other questions as we go on. Right, so I'll start with the disease itself, COVID-19. COVID-19 presents differently in individuals, and there are some common classic themes, signs and symptoms, and these may vary depending on the age. Either of you, can you describe the various ways? Professor Webley, let me ask you this first. Can you describe the various ways COVID-19 presents in the different age groups?
Eve, it's good to be with you again. Good to be with Dr. Wilson again as well in this forum. So, the thing with viruses, especially viruses that are so efficient at leading to infection, is that the only thing that would differentiate them is our own immune response. And that is why you're seeing so many variations. No two immune systems are the same. As you get older, your immune function is reduced in most individuals. And, especially when you hit around age 60, 70, thereabouts, you start seeing that more forcefully than you see it in the younger age group. That is why people in the younger age group are less likely to have adverse events compared to those in the upper age groups. But the common symptoms that you see with COVID-19 are respiratory issues, because that's the main area that the virus attacks. So the virus gets into the throat, gets into the lungs, almost immediately gets into the circulation. What we know now for this virus is that within 10 minutes of attaching to a cell, it actually gets into the cell, right? It gets in very rapidly. The dynamics of fusion and infection is very rapid. What we also know now is that within 10 hours, that is the lag time, within 10 hours, you have new progeny. And that one viral particle can turn into 1,000 within 10 hours. And so in a short time, you start having an immune reaction to what amounts to cell damage as the virus infects cells and bursts out and release cellular contents. The immune system is engaged, both the adaptive and the innate immune system. And so you start having respiratory distress sooner or later as cells in the lower airway gets engaged, mucus gets secreted, blocking some of the alveoli. We now know that there seems to be in some individuals a cytokine storm, where as the immune system tries to respond, just the sheer amount of damage and the sheer amount of viruses in the airway leads to this immune response where you have these chemical messengers called cytokines get released. And this is how our cells communicate with each other. And so in this communication, you also have confusion because inflammation sets in. And so patients now have a reduction in their oxygen saturation in the blood. But we also know that the virus can leave the airways and get into the circulation, which means that it gets taken to pretty much every organ in the body. And the receptor that the virus binds to, the ACE2 receptor, is located in almost every tissue in the body, from brain cells to testicular cells. In fact, a recent research on the genomics saw that the highest upregulation of these receptors actually in the testes and the prostate region.
Wow. So
it's no wonder then that there are gender differences in the way COVID infects and the way the pathology presents itself, and there are age differences in the way this presents itself. That if you actually have an initial upregulation of what we call type 1 interferons, which are what the innate immune system use to control infection, we know that later on you don't have this really terrible inflammation in the lung because that initial innate response is able to lower the viral load rapidly enough. However, if that system doesn't kick in, which we know in some individuals, the virus actually is able to stop that system from turning on, then you have this increase in the viral load and you have an increase in inflammation and a longer period of that inflammation, which can lead to these issues. And then we have long COVID, where months after you would have recovered from this, we're not only seeing issues of shortness of breath and some of the other things that we've seen, but you're seeing individuals with COVID tongue and COVID toes, gangrene. And this morning there was a new one, this mucocutaneous eruption that's associated with COVID, where in this 17-year-old started having these rashes and reactive mouth area on the skin, on the genitalia, all as a result of COVID. So it's varied. In children, we see an inflammatory process, oftentimes that we don't see in adults, but I chalk that up mostly to differences in immune response.
Okay, thank you. Thank you. In the last presentation, you mentioned that COVID-19 affects a lot of people who have diabetes, type 2 diabetes, type 1 diabetes. But recent research has also shown an increase in cases of new onset diabetes. Is there any idea why this may be, or does having a genetic predisposition to diabetes, race, family, lifestyle, etc., do these play a role?
Yeah, I saw that report that a significant number of people who have COVID and have had to return to the hospital after they were discharged turned up with new cases of diabetes. I'm not exactly sure the biological underpinnings of that. I'm not sure if there's damage to the pancreas, to the islet cells. If there is some autoimmunity, which you can have from severe inflammatory infections like this. I'm not exactly sure. Maybe Dr. Wilson has some more insights on that, but it's really an interesting phenomenon. And what it says to us, Eve, is that we're still in the early stages of this pandemic. We still haven't had enough time to figure this virus out.
Right. Dr. Garrick, can you shed any light as to the possible correlation with this new onset diabetes?
Good evening, everyone. It's good to be with you. Good to be with Prof. Webley as well also. I think like Prof. Webley, it's very early information at the moment. And so I don't know more than he's able to tell you. And I think it's also good to put this in perspective. Although it seems as if we've been living with this virus for quite a long time, it feels like it sometimes, doesn't it? But the truth of the matter is that we're still getting familiar with it. It's still very new to the population. We are learning more about it each day. And there are things that we're going to pick up on as we go on. And it's going to raise new questions, and we're going to have to find new answers to those questions. So we're still working a lot of what's going on here. We're still working on that and working, trying to figure it out. And I would say it doesn't yet appear what the long-term effect is going to be down the line. And I think it was very crucial that long COVID was touched on there, because a lot of people are out there thinking that they're invincible to this. But the truth of the matter is you may recover from it, but then the impact that it's had on your physiology, on your body, is only time will tell how long it will take for us to get through that and what it will require for us to get through that. So we're still in the early phases. We're still learning a lot.
Yeah. And still with you, Dr. Garrick, based on statistics, is there any information you can provide us to, is there any information as to why men seem to be a bit more vulnerable than women to the disease?
You know, this question has been asking me a lot, and Prof just touched on the fact that the receptor for this virus is highly expressed in the testes. So that's the testicle, the genitalia area. And that's one theory that's been put out there potentially as to why. There's also other things that goes around, because okay, let's take this back historically, thinking about it. It is often said that men tend to overemphasize and overcomplain when they get the flu virus, for example. Man flu, it's being called. You know, we complain too much. We should just shut up and get on with it, because women seem to be much more adept at dealing with it. And there have been various reports that have come out over time that actually says, you know what, man flu may be a real thing in terms of how it affects the male body. You know, it's to do with things like hormones, your physiology, how all those things are impacted and affected as a result. With the COVID-19 and its impact on the male population, I don't know if some of that is to do with social factors. I would like to speculate that based on some of especially in the UK setting, some of the frontline roles that men are involved in terms of the logistics. One report that came out in the UK last year, for example, suggests that men, Black men specifically, who work as security guards for stores and other companies and so on and so forth, who are that frontline areas where they come into contact with a lot of people, were most at risk from developing COVID-19. And so you'd see a very high frequency of those males being infected. So again, I think there's some social risk here. It could also be the fact, as I said before, that because this virus receptor is upregulated in the testes, that could also be a link to why this is affecting men more than women. And as for other reasons, I'm sure Prof may be having some more information here, but I think that's yet also to be discovered.
Yeah. It turns out from a little bit of genetic search that the ACE2 receptor is X-linked.
Oh.
So there is some down regulation as well of ACE2 by estrogen. So a part of the sex difference might be that you're having down regulation of ACE2 receptors, which is what the virus uses to enter, because of estrogen. But overall, we've always known that women have a more robust immune response than men, also because of the estrogen. Estrogen is just a really good hormone, and we don't have as much of it as men, as women do. And as a result of that, we're seeing a lot of these differences. Also, I talked about when the virus actually enters and type 1 interferon is released, and that actually helps to keep it in control. Well, it turns out that TLR7, it's a cytokine, is also X-linked, and it's biallelic. In other words, it's found on both copies of the X chromosome. And so women have a higher response, type 1 interferon response, than men do overall for any viral infection. And the thought is that they might be able to control the virus in the early stages of the infection better than men are able to. And when you add to that the fact that somatic hypermutation and some of these other immunobiological characteristics make women respond better to antigens. There is a downregulation in B cell activity in men. In males, we see that women respond much better to H1N1 flu compared to men and those vaccines. So there clearly are some clear biological factors that might be driving this. Again, as Dr. Wilson said, we haven't had enough time to collate all of this. But when you look at the data, they did a study on 30-something different countries. Mm-hmm. And when they look at gender, where COVID-19 was concerned, in every single case, we had more men being hospitalized and dying from COVID compared to women. So it's a real thing.
Yeah. Okay. So should men be worried in terms of, should men be worried then? I
think we should be, but men have always had the short end of the stick where diseases are concerned. We've had, more heart disease, more diabetes, more of these types of diseases compared to women. Overall, I think only autoimmunity affects women more than men where this is concerned. So men should always be worried. We're not as quick to go to the doctor for preventative care. And so by the time they catch anything in us, whether it's cancer or diabetes, it's far gone. And this might be a time in this pandemic, seeing the disparity there, to say to men, hey, let us all try to be a little bit more proactive with our health and take the example of women.
If I may segue in there as well, if I may please, Eve. Yes, we should be worried in that we should be more proactive, as was said, about looking after our health. I've come across a lot of men, Black men especially, who I am convinced are showing all the signs and symptoms of COVID-19, and yet they're saying it's just a little cold. It will disappear in a few days. If I have some honey and ginger, that will clear it up and we'll get over it. I'd say absolutely, until you're certain that is the case, please don't have that blasé approach, attitude towards it. I think it's very important we take care of our health. And I like the conversation we've been having here because we're saying men, because that's something that came out recently. And I think there's still some underlying belief here that, you know what, COVID-19 disproportionately affect Black people, Black men especially, because there's something that is different about us biologically, which makes us more predisposed to infection from COVID-19. It's saying we're a readily built reservoir for this virus because there's something that is distinct about our biology. The truth of the matter is, if you're white and you're a man, you're still more susceptible to COVID-19. So let the truth be told, and don't create these biological disparities in saying that, you know what, because you're Black, you're biologically different, and therefore COVID-19 will affect you. And I think that's part of the suspicion around these vaccines, in that these vaccines weren't built for Black people, especially because people are out there driving this idea that our biology is so different, the virus is going to affect us differently in a way. So why is it that we're building vaccines that is not for us? And why is it that more Black people are not included in these clinical trials? So let me just clear that up and say, this is a man problem, not a Black man problem.
I'm so happy you segued into that, because my next question was, there have been a few questions that I've received that, and I get this from both males and females, to say that the participants in the clinical trials included mainly Caucasians under 65, given COVID affected more or is affecting more people of ethnic minority in terms of the mortality rate, etc. Is there any information on what percentage of, two questions out of this. One, is the vaccine then suitable for people of all races? One. And secondly, is there information as to what percentage of the different ethnicities participated in the trials, both in the UK and the US? Is there a guarantee that the vaccines will be effective in both in the different ethnic groups?
Right, who's that towards?
Either of you can start.
Okay, so if I may start, there's no information at the moment to suggest that the vaccine won't work in all racial groups. The vaccine, as it is, will work in all racial groups. In terms of this question around breakdown of participants within the clinical trial setting. I think, let me put some context here, and maybe Prof can deal with the US perspective on this. Certainly from the UK context rather, Black people are very hesitant to participate in medical trials. Black people distrust that entire process, and maybe there's some historical precedence for this. If that's something we can potentially explore later. But Black people are very sort of like reluctant when it comes to clinical trials. In my work where I am, if we try to get anything out there, and London, as you know, is a very diverse city, and we try to recruit people to be involved in those clinical trials, Blacks will say no. You'll hear things such as, from the very strong Christian, it's the mark of the beast. From the politically suspicious, they're trying to kill us out. Others are just, I don't know enough information, so therefore this might be a bit dangerous, I'm not doing it. And others are just taking it along race lines, which is, this is not for Black people, etc. So there is that suspicion on that. When it comes to the vaccine, I think for particularly the AstraZeneca Oxford vaccine, we have to remember that a large bulk of the trial was done in Brazil. Which mainly involves people from ethnic minority background. And the data coming out through that trial is basically solid in that the vaccine worked there. And I think with the the Pfizer vaccine, you may be able to correct me here, Prof. I think around 10% of participants there were Black people. So we do have Blacks and other ethnic minorities that have been involved in the development of these vaccines at a very low level, I must state, but based on the reasons I've just given, there's this suspicion about being involved in these trials, which means it's not readily done by people of ethnic minority background.
Yeah, completely agree. That is the key. There is hesitancy there for good reasons. But I don't know for the AstraZeneca vaccine, but for the Pfizer and the Moderna vaccine, just about 9.7, 9.8% of the participants were Black. Here's the trick with this. There is an assumption that Black people don't want to participate in clinical trials. And not a lot of effort goes into trying to recruit them. So when you look at the data, you'll see that a company will repeatedly go and try to recruit Caucasians into clinical trials of any type. And they will put in 1/10 or 1/100th of that effort to try and recruit a Black person into the same trial. They give up almost immediately on a Black person who might seem hesitant. There is an assumption, there's an underlying assumption that African Americans or people of African descent do not want to participate in clinical trials. My take on it is that if enough time is spent explaining the study, explaining the benefits of the study, explaining why it is that it's important that people of all races and all age groups and all ethnic backgrounds participate in a trial, especially of something like this, the nature of something like making a vaccine, that is better for your race. You're doing something for people in your racial group, in your ethnic group. I think more minority people would participate in these trials. The other thing is, we often look back on the historical treatment of African Americans, the Tuskegee syphilis studies, the issue with Helena Lacks and the cells and the exploitation, and Marion Sims and the gynecological exploitation of African American of African slaves, frankly. But recently, I've come to the conclusion that a lot of the hesitancy that we see today with minority groups is because of the way we're treated right now. Mm-hmm. When you go into a facility and, a medical facility, and your Caucasian counterpart gets attention repeatedly, and you're pressing the button for help from a nurse, and the nurse doesn't come, but when the other person who is white right next to you press the button and they come, that reduces your trust and your level of trust in the healthcare system. When you get the perception that they care more about another group than they care about you, that reduces your trust in the system. And so I think, again, institutional racism, structural racism, that sets up a system that benefits one group over the other, you're always going to have mistrust. And people are not averse to this participation. They just need somebody to assure them that your participation matters and that you're safe in that process of participating.
Let me comment on that really salient point, Professor Webley. So apparently the UK is not institutionally racist, and yet you would have Black mums going into the maternity wards and maternity units, and a lot of them die in childbirth or after childbirth. And yet when that's compared to white mothers going in to give birth, it's completely, it doesn't add up. Something is distinctly different there. You have a lot of Blacks being sectioned and given high doses of antipsychotics, disproportionately above levels that's required, because there is this practice out there to say that Blacks generally tend to be more aggressive and therefore they need to be dosed up more in terms of the drug regime. So there's all of that. And you're right in to say that there are some now contextual reasons why Blacks do not trust. I remember when my mom was unwell, and may sorry, rest in peace, she's passed away now, and she used to visit the hospital, go to her doctor's appointment. I would have to go there and sit with her because she communicated like a Jamaican woman, had no shame about it. Go in to see the doctor. The doctor said, "How are you feeling today?" She would express herself in ways that perhaps, they would just ignore. So she would say, for example, "I feel like an elephant is sitting on top of my head." That will mean nothing to a white doctor, and they will just dismiss things like that, etc. So somebody like me had to be there to sort of be that bridge that sort of translates to ensure that she gets the appropriate attention and the appropriate treatment. I say all of that to say that there is, you spoke about education, there is this thing that we need to grow up now and stop waiting for the system to change and address our problem. We also need to be proactive in actively taking part in actually challenging the system. Yes, Blacks may well be more receptive towards being participants in medical trials. However, if you're not the door the first time, they're not going to answer. So what do you need to do to ensure you get the answer over time? I think church groups, community groups, other social organizations, your neighborhood watches, your school boards, whatever it needs to be, can come together and begin to have these bigger conversations as to what we need to do to make sure that our communities are bolstered. If ever such a thing ever happens again, make sure that we're not left at the back of the queue, at the bottom of the line, or whatever you want to call it, to make sure that we're receiving the proper help and treatment that we need, and that we're actively engaged and participating in these processes, because there is enough of us out there who are trained in these areas that can go and speak to and educate our people and be proactive instead of reactive, because a lot of the times we are reactive in that we follow up with something after the damage has been done. No point in calling the fire service after the house has been burnt down. And I think we need to stop watching the house being burnt and saying that the system needs to change for us and do something about it. The system is completely despicable. I think it's deplorable in many of its ways, and I completely call it out for that. But hey, call me passionate. I'm sick and tired, and enough is enough. There you go. Rant over.
Thank you. Thank you very much, Doc. Well, for those of you who are tuning in, thanks again for joining us. And I do hope that your questions have been answered so far, and that you are learning, you're being educated, you're getting something out of this, because it's about you tonight. So I want to thank the doctors so far for for what they've shared. On the concept of efficacy, we've seen a lot of back and forth regarding information about vaccine efficacy put out by the government, especially here in the UK, and I'm sure in the US as well. And a lot of deliberations around the Oxford AstraZeneca vaccine, but we'll get into that in more detail. 1 minute is 65%. Well, I'm not sure if it's been down to 65, but just say 85. And then it moves, it changes. So, so things like that. Now, when we speak about efficacy, because I think people need to understand what this means. When we talk about efficacy, what does this mean? And is efficacy the same in all ethnicities? Dr. Webley, Professor Webley.
Yeah, so efficacy is the ability of the vaccine to prevent symptoms. And in this case, they're looking at efficacy in being able to prevent all symptoms from mildest right up. So the the Pfizer and Moderna vaccines are approximately 94 point something percent efficacy. Now, efficacy is a good measure, but it's not really the important measure in vaccinology. The important measure is the ability of the vaccine to prevent serious disease, to prevent hospitalization and death. You know, that is what you want to look for in a vaccine. So to that extent, all of the vaccines that are currently out on the market are able to do that. They significantly reduce the probability of you getting sick and being hospitalized or you dying. And so with the AstraZeneca vaccine and the differences in reported efficacy, that is to be expected. And the reason for that is that all of these vaccines are being used under emergency use authorization, which means that the phase 3 clinical trial is still ongoing. And as you add more people, as they go back and they look at the data, so let's say initially, when you open up the data and you looked, you realize that, oh, you know, we had 100 people who were infected in the trial, and only 5 of them were in the vaccine group, right? So now you're saying, okay, we have a 95% efficacy. But 3 weeks down the road or a month down the road, you open up the trial again. Now 350 people are infected, but this time 100 of them are in the vaccine protected group. So now you know that the efficacy has changed. So it's not that they're lying about stuff. They might want to see, like anybody else, want to see a high level of efficacy. But you have to remember that if you have a 50% efficacy, your vaccine will be approved. You know, the FDA approves vaccines that are 50% efficacious. And so it's not that you're having some lower threshold. The AstraZeneca vaccine in the US trial was about 76% efficacious in being able to prevent the onset of mild symptoms. So in my opinion, I think that the conversations around efficacy, and especially comparing efficacy of one vaccine to the other, is like apples and oranges. If you're not actually doing a head-to-head trial, you can't really compare efficacy. You know, the AstraZeneca vaccine was created after the Moderna and Pfizer vaccines, which means that it was tested on people who had variants. The initial vaccines weren't. And so, you know, we know that when you have these variants, these mutations from the initial virus strain, that the efficacy level goes down because you're not being able to block and prevent and neutralize the virus at the same rate. So I think trying to compare different vaccines that were tested in different countries, in different groups of people with the other is just not an effective way to go forward. What you have to ask yourself is, does this vaccine prevent me from ending up in the hospital on a respirator or dying from this disease? And if it's able to do that, then that's a good vaccine to take.
Thank you. Thank you. Just want to acknowledge some of the comments on Facebook. We have Shika saying the statement about trying the vaccine in Africa first has contributed to people's fears, and that the system definitely needs changing. Thank you for that, Shika. We know that immunity starts, well, we are told, immunity, you know better than I do, that it starts taking effect, say 2 to 3 weeks post-vaccination. And this immune response, it wanes after a few months. Question is, how and when will we know the duration of the immunity we get from these vaccines? Dr. Garrick.
Thank you for that.
And then Dr. Webb.
Thank you for that. So you're right. There's some information that came out, especially within the UK setting, to talk about the fact that around 2 weeks after getting the first dose, depending which vaccine you got, you would see immunity coming through. There's then subsequent data that went after that to show that immunity can last anywhere up to 5-6 months. Just from that initial dose alone. And of course, then the belief is that after the second dose, it should confer a longer term immunity. Exactly how long that will be, I mean, Professor Webley probably can tell me more on this. Exactly how long that will be, we just don't know yet. We really don't know yet. And so there is this suggestion now, especially within the UK context, that what we may end up having to do is an annual jab. We may end up having to take that. And that's in light of new variants coming through as well, that we may have to go back, tweak the formulation and get an annual jab. But if you think about it like this, if we are having 5 months immunity from just one dose alone, when we get the second dose to get that booster, I think that should confer long-term immunity. And I think that should keep us safe for quite a long period of time. However, with the arrival of new variants, that may be where the tricky part comes into it. And that's where we may need to go back and get a vaccine.
Yes, because now they're talking about a booster, third vaccine.
Yeah.
So.
Yeah. So yes, and I think that third vaccine booster is to do with the fact that we see new variants coming through. So we've seen those 2 variants in the UK population. We now know of the South African, also the Brazilian one as well. And we can't keep our borders closed indefinitely to flights and people traveling, because that's good for economy. And once people coming in and going out of the country more, we're going to need to find ways of protecting the public's health. And so if that means tweaking the vaccine formulation and keep adding a booster, I think that would be a sensible public health approach to take.
Yeah, the immune system is pretty remarkable. That within minutes of encountering the vaccine antigen, your body already has started mobilizing to respond to it. So it's not that the immune system is slow to respond, it's that our detection systems detect it, several days later. And that 2 week is at the peak, where in terms of antibody production. So we know that it takes about 2 weeks to reach that peak level of antibody production because of several processes, several immunobiology processes, where you have to have a clonal expansion. Not every immune cell in the body responds to the spike protein of COVID-19. Only a small number of cells will respond to different parts of it. So now you have to clonally expand every one of those cells that respond to it. And that's what takes the time, because your immune cells are only going to divide about 1 time each day. So, in order for you to get millions of cells responding, so you can spew out millions of copies or billions of copies of antibodies, it takes time to get up there. Now, the question is, what is the half-life of that IgG antibody, that protein that is being produced? And that's probably about 50-something days. That will sit around normally. But if you continue to push them out, and if you induce memory cells, which recent data actually shows, looking at using a new technique to look at the lymph nodes under the armpits, for example, they've shown that you actually have germinal centers producing memory cells, both B and T memory cells, against the vaccine. Memory cells can live up to 30 years. See, if you have enough memory cells in the system, then you should continue to produce, and long-lived plasma cells in the bone marrow, you should continue to produce antibodies and have an effective protection. Now, is that level going to drop? It absolutely will. And what they've seen recently is that after 6 months, you have a drop in almost half of the initial antibodies around 2 weeks after your first shot. But the amount of antibodies there is tenfold higher than what you would have normally with a regular infection, which means that you still have tons of antibodies circulating in your system. So I don't expect that this will last less than a year to 2 years at all. In fact, I expect it to last well over 3 years before you'll need a booster. However, what Dr. Wilson has said is really well taken, because the longer we continue to have these surges, the more likely it is that we're going to have variants. That's all it takes for you to have variants, for the infection to be going from one person to the next. We talk about this virus as the virus, but really what it is the viruses, because every single person who gets infected, you're having variants. These viruses make mistakes when they're copying their genome. And many of these mistakes are deleterious. The virus is not helped by them, but every now and then the virus gets lucky and it makes a mistake that actually helps it and boosts it. And the more we continue with this pandemic, the more likely you have. And here's where the vaccines become important. Because we've seen in the populations that have been vaccinated that you have a significant reduction in infection. We have a significant reduction in hospitalization and death in that group, which means that if we do that for every age group, we will significantly reduce the numbers of new cases of COVID-19 that we're seeing. And that simultaneously will reduce the amount of variants that we're seeing. And the quicker we can do that, it's the less likely it is that you'll need a third shot.
Thank you. But regarding these variants, though, is there an increased risk of transmission? Yes. Or do they have a higher probability of escaping the immune response? Do they become less virulent when they replicate?
No indication that they do. In fact, the B117 variant, not only is it more transmissible because it binds more tightly to the ACE2 receptor, has a higher affinity for it, but it is also clear now from data both in the UK and the US that it is actually more deadly, right? By mere numbers, if you're having more people infected, then sooner or later you're going to have more people being hospitalized, and the more people hospitalized, the more people die. And so just by those numbers overall. So these viruses, you could have mutations when the B117 is in the system, and some of those mutants could be less effective. But those less effective mutants are not going to take over. The more effective ones, the ones that are more transmissible, the ones that maybe produce a larger burst of viruses when the cell opens up, those are the ones that are going to dominate. And right now, the B117 is the most common variant in the US, in the UK, and probably in other parts of the world. I don't know if people have been following Brazil, but in October of last year in Manaus, Brazil, they had one of the widest level of infection that we've seen at the community level. In fact, it's estimated that about 70-something% of people in Manaus got infected with the initial B strain, the Wuhan strain of the virus. And the number of infections went down significantly after that. They weren't seeing people getting infected and getting hospitalized. And so they became pretty comfortable, and it gave us some idea of where herd immunity might be, because here's herd immunity in the natural. In February, the P1 strain, end of January, February, the P1 variant popped up in Brazil. And the number of cases in Manaus started going up. What they found out is that these people who had already been infected with that B strain were now being infected again with the B1 strain. And now the deaths went up again. Mass graves were created again. And right now, this is ongoing in Brazil. So we have to be very thoughtful. So people say, oh, I don't want to take the vaccine, and oh, it's okay, I'm not going to die if I get this virus, or I've already gotten the virus, so I don't need the vaccine. Manaus is a case study, sandboxing of what can happen if you have that sort of notion that, number one, you don't need to take the vaccine, or number two, if you've already been infected by whatever strain you probably don't even know, then you won't get infected again. Simply not true.
And I think that's a solid point to make, Professor Webley, in that by refusing to take the vaccine, we give the opportunity for new variants to arrive and become prevalent within the population. And that puts us back at square one potentially. And that's what we don't want to happen. And I think just looking at the data that's coming out of the UK at the moment, where I work, Imperial College London, what we do is do a surveillance of the population, the circulating levels of virus in the population from time to time, just to see what things are looking like. And since the rollout of the vaccine has started, we have seen infections drop by about 92% in terms of circulation within the population. So I think that is a success based on our vaccination program. In mid-January, weekly, we were looking at death rates around the 8,000 mark per week. Now, mid-March coming up to now, we're looking in the hundreds, nothing over 800. That's sharply reduced because a vaccination strategy is being rolled out. And that obviously gives the virus less of an opportunity to mutate and new variants to come through and dominate in the population. So there is another reason why we should take the vaccine, because as Prof says, you may think I'm young, I'm fit, I'm healthy, I'm going to recover from this. You may be a breeding ground for new variants to come through. So keep that in mind as well.
Thank you. Just answered a part of the next question. Someone did send this through as well. Why should people take a hastily constructed experimental gene therapy gene therapy whose long-term effects are unknown, as these are manufactured by companies that are indemnified against prosecution in the event of serious side effects. You've answered that, but we know.
That's a loaded question
I
with
know.
a lot of misinformation. The vaccine is not gene therapy. It wasn't hastily created.
Hmm.
The mRNA technology is something that has been around for over 20 years. In fact, before COVID-19, there were lots of phase 1 clinical trials in place for mRNA vaccines, human trials for mRNA vaccines for stuff like Zika virus and even the H1N1 flu. So this is not a new technology. And there's good explanation as to why these vaccines were expedited. You wouldn't want us to be sitting around waiting to create a vaccine so that we can abide by some arbitrary timeline that would make somebody comfortable. You make these things as fast as you can. When you get sick and somebody calls the ambulance, you don't want that ambulance sitting in traffic just to be nice and cool and not wanting to disrupt somebody's afternoon. You want that ambulance getting through, people pulling over at both sides of the road, they cautiously going through red lights so that they can get to you on time. That's what emergency use authorization is. It's a system that's already in place so that if you need to create something quickly, you can have it. The idea that these vaccines are gene therapy, I don't think this individual understands what gene therapy is. Gene therapy is when you take a specific stretch of DNA and you integrate it into the host DNA with the sole purpose of altering what is already there. This is not gene therapy. This is what viruses do. When viruses infect you, they actually use your cellular machinery, since they don't have any of their own, to create their proteins. Mm. So when COVID-19 infects you, it instructs your ribosomes, your machinery in your body that makes proteins, to make all the proteins that it needs, right? This is a 30 protein virus, a large virus, and all of those proteins are produced by your own cells. All that the scientists have done is that they said, oh, that's a good idea. The virus does it, we can do it. Let's give the body the instructions to make the spike protein that the virus needs to enter so that your immune system can respond to it. That's all that the mRNA vaccines are. For the AstraZeneca vaccine, a viral vector vaccine, all that is happening is that you're sending in a piece of DNA that's going to be now read and turned into an mRNA that the body is going to use to make the protein so that your immune system can see it and gets primed against it so that you can protect yourself from this virus. So there's no gene therapy going on there. And this is easy to understand technology.
Mm-hmm. Absolutely. I completely concur with that. And I think a lot of the time when people put these information out there, I'll say this, a lot of this has been spread by WhatsApp, for example. Yeah. Before you press send on a message, make sure you verify the source and make sure the information is correct, because this just proliferate a lot of misinformation. One thing that the UK Prime Minister said recently, he says that capitalism works when it comes to vaccine development. And really that was his way of saying we've poured a lot of money into our research and development infrastructure to just bolster that so that we can respond to the pandemic appropriately. And a lot of money have gone into vaccine development, not just by the UK government, but by other governments around the world as well, which means that what normally takes a long time because of a lack of funding can now actually be done at a greater speed. It doesn't mean we've cut corners. It doesn't mean that all the safety mechanisms and the protocols were stripped out of it. And you see, and a lot of times when we speak about it's too quick, it's because we don't understand the process of vaccine development. And we don't understand, as Prof. Webley said, that these technologies are not new technologies. They've been in use for a period of time already. Now we have the capital, we've got the money to put behind it to make sure that when we do our preclinical trials, that's the stuff we do in the lab settings, it means that once we have confidence in that, we can move on straight away to the clinical trials, not because, and oftentimes we're hesitant to do that because we don't want to waste a lot of money on something that's not going to work. But when we have a readily amount of money now through governments to say, you know what, we're going to fund you, keep going, then that restriction is taken away. And it means that we can go ahead with all the different phases of the clinical trials. And then there's the other side of it as well, the manufacturing and development and distribution side. We have to be engaging with those partners out there, how we're going to get this thing manufactured and delivered at scale. And of course, the regulatory side. Normally, all this information is in place before we take it to the regulators. But at every step of the way, the regulators are being involved, looking at the data coming out, looking and scrutinizing it in an independent way to come up with their own conclusions. And because we have streamlined and we put all of this together, it means that we're where we are today. And I think it's absolutely beautiful for the future of healthcare in particular, in that we can move at such pace, especially when government decides to move and back it with money. So there are no corners are being cut. And I think I want to show the public of that. Absolutely no corners are being cut.
Thank you. Thank you for that. Thanks for the clarity. I'll just crack on with the questions. We hear about the emergency authorization of the vaccines and the different, here we have the MHRA, we have is it WHO or the FDA? FDA. Is that FDA approval? Is it the same or is it different?
So you have emergency use authorization and then you have full approval.
Has the vaccines been fully approved by the FDA?
Yeah, so none of these vaccines are yet fully approved by the FDA. Because, remember that these companies recruited 30 to 40,000 people into their clinical trial. Mm-hmm. In the protocol, they have endpoints that they need to reach, right? In other words, they put in clauses that for the regulators, so that the vaccine companies are not the ones that regulate the clinical trial. They have independent regulators that regulate the clinical trial. And so the regulators are the ones who go in and look at the data. So you have to put in specific clauses as the vaccine company to say, okay, when you get to 100 people infected, I want you to pull the data and look at who is in the placebo arm and who is in the vaccine arm. And then again, when you reach 200 or when you reach 500 or thereabouts. So what is required is for enough people from enough backgrounds, with enough underlying conditions, with all of those things in place to become infected in the trial, for the trial to actually be given full approval, for the vaccine to be given full approval. So, although these vaccines are being used under emergency use authorization, the fact is that, as of today, I think it's something in the order of probably 500 or probably more now, 710 million people worldwide have been vaccinated with one of these vaccines. That is a trial all by itself. We talk about phase 3 clinical trial, but when you have a drug, there's actually like a phase 4 trial when it's in the public. You continue to look at every symptom, everything that people report in. That's a part of the trial that you continue to look at that. So sooner or later, these companies are going to go for full approval. They just have their hands filled right now, trying to make vaccines to supply, because supply is still low in most places in the world. Sooner or later, they're going to apply for full approval for these vaccines.
Let me just add to that briefly, just to cover this. So within the USA context, it is the FDA that gives that emergency use authorization. Within the UK, it's the MHRA. And if we're looking more continental Europe, it's the EMA, which is the European Medical Agency. So we have these different bodies based on where you're at, who will look at the data and make decisions independent of government for the local context. So I thought I'd just clear that up.
Yeah, thank you. Can vaccines alter? This is such a common question, and I'm sure for you as well. Can it alter your DNA? Can the vaccines alter your DNA? Anyone of you can say that.
No.
Go for it, Prof.
No.
The answer is no, but go for it, Prof. Because
here's the thing. Your DNA lives in the inner compartment of your cell called the nucleus. Not every protein in the body can enter the nucleus. For a protein to enter the nucleus, it needs what is called a nuclear localization signal for it to be able to bind to the nuclear port and get in. Moreover, for it to be able to alter the DNA, it needs to have specific ways of cutting the DNA, maybe cutting out a region, because 98% of your DNA is not genes, right? That's important. Not every part of your DNA is genes. Other parts are regulatory regions. And you literally have to get into a gene in order to be able to alter DNA. So when the vaccine is given, what you're actually getting is a messenger RNA for this vaccine, and also for the AstraZeneca, for the vaccine, you're getting a chunk of DNA that codes for the spike protein. That's all of the vaccines right now, or the vast majority of the vaccines right now, they're targeting the spike protein. So essentially, your body is being instructed to make a protein. That protein is made in the cytoplasm of the cell, that outer compartment. And once it's made in the cytoplasm, it goes to the Golgi, which directs it and tells it to be excreted. It gets outside of the cell. That protein gets broken down by the immune cells, because that's the only way the immune cells can identify a protein. They identify it by sequences, by amino acids, the building blocks of the protein. And so they read the amino acids, and specific immune cells respond by further chewing it up. So the truth is, a few weeks after you've gotten that vaccine, if somebody should test your blood, there'll probably be zero trace of any of those proteins in your system, or the vectors that they use to get them in. Because proteins just don't hang around in the body for a long time. They're broken down. Antibodies that are made in the body are broken down because they're proteins as well. Every single protein in the body has some sort of a half-life, right? And so when people say, oh, this is going to alter the DNA, how do we know that you're not going to have some long-term effects from this vaccine? We know that you're not going to have long-term effects from these vaccines because these are subunit vaccines. They're not giving you a live microbe that sits around in your body for any period of time. After a while, those proteins are just completely depleted from the body after they've done the work that they're supposed to do, which is what? Which is to tell the immune system that here is something you should be looking out for. So these proteins, all they're doing is like sending a fax or an email to your immune system saying, hey, here's a pattern that you should be looking for. The immune system mobilizes. That email is self-destruct, like Mission Impossible, right? This message will self-destruct in 5 seconds after you get, it's not exactly 5 seconds, but soon thereafter, these proteins are gone through a process that the body uses to get rid of proteins that have been around for a while.
Thank you.
My response to that briefly, it would be, before you buy into these misinformation, it's so important you understand how biology works. And what is being suggested here is against what we know about the fundamental laws of biology. And that's what Professor Webley alluded to, in that you have to have that nuclear localization signal. Think of the nucleus as its own compartment altogether. And it's got doorways, we call those pores. In order to get through those pores, you have to have a specific access card. Nothing within the piece of RNA genetic material, which is in the vaccines, contain any form of nuclear localization or signals that will allow them to get through into that nucleus. And therefore, there's absolutely no interplay or interaction with your genetic material whatsoever. As we make it very clear, sounds RNA, sounds similar to DNA, and I think that's where a lot of people are drawing the conclusion from. It simply carries the information and how to make the spike protein of the virus. When it gets into your body's machinery translates that and build that protein, which, as was said, will then create or help to stimulate that immune response. So there is no question here about genetic manipulation, gene therapy. Can I once and for all say that's foolishness? And I'm going to put my foot down on this one. That's absolute foolishness. And it's time we stop that conversation.
And even if any of these things could actually change a DNA in a cell, what cells are you injecting this vaccine in? You're injecting the vaccine into muscle cells of the arm that have already been terminally differentiated. These cells are not going to become brain cells. They're not going to become any other cells in your body. In order for you to genetically alter something, you need to get to the cells that actually divide and differentiate into new cells and tissues, which means that you either have to get to the sperm and egg cells, or you have to get to the multi or pluripotent stem cells in the bone marrow. Right? So people think that, oh, you just alter, if I alter the DNA in one of your cells, that's more than likely going to have zero effect on you because those cells also have their own half-lives, right? And so you're not going to pass it on. It's not going to change any of your other cells because these are what we call somatic cells. In order for you to alter effectively the genetics of an organism, you need to alter it in the germline cells, not in your somatic cells, right? So that's why when somebody has cancer, for example, you can ablate their bone marrow, kill off all of the cancer-causing cells, and then allow their cells to grow again, and they're fine. Why? Because not all of the cells in the body have that genetic defect overall. So again, as Dr. Wilson said, I love doing this with him because the knowledge is just so much that, you know, this is all foolishness. There are specific biological rules that govern us. And you know, what surprises me sometimes are the same people who go to church and say, oh, we're so fearfully and wonderfully made. And then they make their God look like he doesn't know what he's doing, right? It is really disheartening. Yeah. If you're so fearfully and wonderfully made, you need to take a little time and understand this biology of how you're made, because this biology is solid. You know, you can't just put some little thing into the body and all of a sudden you're changed and you're transformed into, you know, this crazy monster that you see in some movie. That doesn't happen. The body has specific ways of guarding against any sort of damage. Look at how much we abuse our bodies, and we're still able to walk out and dress up nicely and say, look how good I look. You know, the body doesn't change that easily.
I think fear is a hell of a thing, really. And it generates a lot of these feelings and these misconceptions in people's minds, you know.
But it blows my mind that you're able to believe these ideas, but yet it's harder for you to believe the science. With evidence after evidence after evidence. It says that what we have done is that we've gotten pretty lazy. We don't read. So every little video on WhatsApp becomes truth because we don't want to go and read the information for ourselves.
That
right?
That is so true, and you preach there, Professor. Amen, says the church. But what I'd add to that as well, I think initially when this started, those, you know, pushing these misinformation, the conspiracy theories, they got ahead of the real professionals in delivering or disseminating information. And I think as a result, here we are now playing catch up to try and, in fact, instead of putting out there the real credible information, what we have to be doing is discrediting a lot of what is being proliferated. And I think that's just the problem, in that when this started, everybody got a PhD, everybody gained suddenly, and everybody was an expert at everything, virus, vaccines, and so on and so forth. And it's really unfortunate. And I think part of that, my suspicion with this has always been, is that the conspiracy theories got ahead of it, and also politicians who people don't trust got ahead of it. And they should have been left from the very get-go to the professionals to deliver the information. And we would, I suspect, would have been in a better place right now.
Amen to that.
Thank you. Wow. I just want to say welcome to those who are, I see people hopping in and out of Facebook, but thanks for joining us nonetheless. And remember to share and like and make your comments, ask questions. Professor Webley mentioned a few side effects, you know, minor side effects from the vaccine in his first presentation about on the topic. Things like fatigue, nausea, dizziness, and so on were mentioned. And these are all self-limiting side effects. However, there are concerns, obviously, there are concerns about long-term side effects from the vaccines. First question. The initial reaction or response, side effects that people have from the vaccine. Some people have, some people don't. What is this a good thing, and what is it telling us? And also, are there any reports about serious side effects such as death or disability as a result of the vaccine? I'll go on to the AstraZeneca issue in a minute, in more detail, but just generally asking, are there any serious adverse effects that directly associated with the vaccine or disability as a result of these? Any one of you can take it.
So yes, there are individuals who can have an allergic response to components of the vaccine. It's not clear at this stage what it is that they're responding to, but people do have allergies. And if they have anaphylaxis, which is a systemic allergic reaction, then that is something that you can have. But the vast majority of people don't. The number of severe responses to the vaccine is extremely low overall. The reactions that you see, the pain at the injection site, the fatigue, the fatigue comes from immune response. When the immune system is mobilizing, it takes quite a lot, and that mobilization is going to lead to sapping up energy. In fact, I recently saw a paper where they used to, for PET scan, for example, use glucose to track where you're seeing cancer cells growing. Well, it turns out that it's not the cancer cells that's utilizing all that glucose. It's actually the immune cells that are doing it, right? So that immune response is what is actually driving some of this fatigue that people feel. The other types of side effects are a combination of physiological responses. When you have a damage, you push a needle into somebody's arm, there's damage there. The arachidonic acid pathway is activated. You have all of these products coming from it so that you can have repair of damaged tissue. If there are any microbes there, that those can be taken up and all of that. And that's going to feel a little painful, especially if you're not somebody who works out often. After I got my first shot of the vaccine, I spent the afternoon raking up leaves in the yard. I never had a single pain, not even a tiny little bit, right? So, and other people have seen the same thing, that if you go out and you do some activity after that, the repair process is enhanced.
Thank you. Thank you. Dr. Webb, Professor Webb, you mentioned in your last presentation components of the vaccine. Someone is asking, do the vaccines contain the live virus? And does it contain animal products such as beef, pork, gelatin, things like that?
No, I mean, there's no virus in any of the vaccines that we have approved in the Western world. These vaccines are, for all intents and purposes, subunit vaccines. What they're doing is that they are giving the genetic material for making the protein. You see, before we used to make the protein, purify it, and inject it in. It took a long process to do that. With these new mRNA platforms, they just put that product in, and the viral vector platforms, they put the code to make the protein in, and the body makes the protein. And you get vaccinated against it. There's no product like that in them. For none of these vaccines that are approved have any animal products in them or any human products in them. They have lipids in them, but a lot of these lipids are proprietary lipids that are synthesized. For the mRNA vaccine, for example, for the AstraZeneca vaccine and the Johnson & Johnson vaccines, these are viral vector vaccines. In other words, what you actually have are viruses, but these are not coronavirus. These are viruses that have been modified not to cause disease. They didn't cause disease in the first place. They're modified not to replicate. They're just a Trojan horse taking in the sequence to make the spike protein. So there's no such thing in the vaccine to cause problems. And when you talk about long-term issues related to the vaccine, again, the vaccine antigen is not going to be around. The FDA did a study, the Food and Drug Administration here in the US did a study and looked back on the last 50 years of vaccines that they've approved. And what they showed is that nobody had any side effects that you could attribute to the vaccine after 2 months of having gotten the vaccine. Why? Because vaccine products just don't sit around for that long period of time. And especially with the fact that they're protein-based or a combination of proteins and carbohydrates, they're going to get degraded. They're not sitting around in your body looking to cause trouble.
Can I just add as well, the majority of the vaccine is water. It's water-based. You have either your viral vector in the case of the Oxford AstraZeneca case of the Moderna, Pfizer, it's your RNA encoded in a lipid, as Prof just said. And in addition to that, you may have things in there like preservatives to keep it stable, to modulate the pH, or rather to stabilize the pH. And depending on the formulation as well, you may have an adjuvant in there, something that's going to help to boost your immune system all the more. So those are the constituents. It's mostly water, and that's not going to have any adverse effect on your body. And of course, as Prof said, these things are not going to hang around for long to do anything to you.
Yeah. In fact, the interesting thing about these vaccines is that none of them have any adjuvants in them or preservatives. The mRNA vaccines don't even have adjuvants in them because they don't need to. And they don't have any preservatives in them. That's why you have to keep them frozen, right? And so, you know, for the AstraZeneca, there are little stabilizers, but they're mostly sugar mixes that are able to keep your plasmids alive, so your viruses alive. So again, these are probably the safest vaccines in terms of additives that we've ever seen.
And in terms of the preservatives or the stabilizers, a lot of people are saying if there's sugar in there, I've heard this, so let me just address it, that is going to give you diabetes and this, it's there to affect your blood sugar and so on and so forth. Can I just say the trace amounts that are in these vaccines are absolutely not going to do or have any adverse health impact on your bodies. So please, let's not just hear words such as sugar and we take that to mean something else, or words such as RNA, we take that to mean something else. Let's be quite wise in our discussion and our understanding of that.
And lipids don't mean pork.
That's absolutely right.
It
also
just means fat.
That's absolutely right.
Thanks for the clarity. And that is as clear as day. Okay, right. As animals were used in some preclinical trials, I'm not sure if it's all of them, but can vegans take the vaccine?
Yeah, the vaccines are not food.
Yep.
You know, it's not something that you're eating. It's a therapeutic. And of course, preclinical trials have to involve animals. You know, for a long time now, we've known that it's not safe to bring anything into phase 1 clinical trial until you've actually checked it out for safety in animals. Because if it's killing every mouse that you put it into, you certainly don't want to put it into a human. The same folks who complain about that would say, you see, you can't trust these people because they take stuff that's killing people. And so you try to get some idea of dose based on grams of body weight. You try to get some idea of, you know, while our physiology is different from the mouse, there are lots of things that are similar. You know, you try to see if there's an immune response, because if there's an immune response in the animal host, it probably will give you an immune response in the human host. So yes, there are preclinical trials that are used. However, once you get out of that and you get into the human system, for these mRNA platform vaccines, again, they don't involve any animal product. They're not grown. These are not grown in any cells. These are just synthesized in the lab. For the Oxford AstraZeneca vaccine and other viral vector vaccines, the viruses that you're using as a Trojan horse have to be grown in something. And so these viruses are grown in human cells because you want a compatible system to grow them up. But none of those cells ever make it into the vaccine product itself. The vaccine product is purified of any human or animal cell or even the DNA from that. And while we can't guarantee that there's not a single base pair in there of human DNA constituents, you can guarantee that there are no stretches in there because it's highly purified of those things, just the way you get to the virus. There is no reason why somebody who's a vegan should object to something like that, because you're not getting a product, a nutritional product that you're eating. So it would not alter or violate your commitment to being a vegan.
I think it raises an ethical question, isn't it? But there's an organization called PETA, or PETA, PETA, and it's for people for the ethical treatment of animals. And I've gone and looked up a statement, and it was a statement about the Pfizer vaccine data. And it says, according to PETA, the vaccines do not contain any animal-derived ingredients, and also states, as long as tests on animals are a legal requirement. Refusing to take the medicine on ethical grounds will not help animals who have already been used in tests or spare any the same fate in the future. So yes, I do agree with you. Vegans can indeed have the vaccine. How do how do you determine which vaccine is offered to an individual? Do specific groups take a particular vaccine? And is it a matter of cost over efficacy? I know just maybe in the last 24, 48 hours, we're hearing that young people in the UK, I'm not sure about the US, should be offered an alternative, given the debate around the AstraZeneca vaccine at the moment. But is there a determination as to what do you give to this individual versus that individual?
So I can speak on the UK context, and then perhaps Prof can go more widely. So initially in the UK, there wasn't a choice as to which vaccine you get. It is a case of what's available at the time when you turn up to take your vaccine. And that's really was seen as the fairest way to distribute the vaccines. However, some individuals, as they begin to raise concerns about underlying health condition and what taking a particular vaccine might mean for them, were signposted to their healthcare professionals, providers, to actually discuss the specifics of their underlying health conditions and as to how that may be impacted or affected by a particular vaccine formulation. So there are cases based on that, based on what the factors are, that may lead you to getting a particular vaccine. But in the UK, generally speaking, it's what's available when you show up. Now, given the recent issue that's been reported with the AstraZeneca Oxford vaccine about this risk of blood clots, and I'm sure we can go into that in much more detail shortly, the recommendation that came out from the regulators here is that it should not be offered to individuals under the age of 30, so the younger age group, and that either the Moderna or the Pfizer vaccine should be given to them instead. So now they do get that choice as we see ongoing development. And as Prof said earlier, we're still in a sort of phase 3 trial here, and we're going to see things changing, which means that the regulators are going to have to adapt based on the information as it presents itself and makes further recommendations. And that's partly what we're seeing here. So that age group will now certainly be able to choose which vaccine they get, which will not include the Oxford AstraZeneca vaccine. But generally speaking, in the UK, it is what's available when you show up for vaccination, and that's what you're given.
And the U.S. is pretty similar too. It's what is available, but you know, with the wider distribution of vaccine, of course, we don't have the Oxford AstraZeneca vaccine is not approved in the U.S. So we have the Moderna, Pfizer, and the Johnson & Johnson. And what is happening now, since the pharmacies, local pharmacies, and centers are now giving vaccines, when you go on to select your appointment, you can select the type of vaccine that you get for that appointment now. And so that is changing in the US as these three vaccines are made more widely available. However, again, with the Oxford AstraZeneca vaccine, with the blood clotting issues that they're trying to work out, there is a reason for giving people choice. You know, people below 30 are less likely to die of COVID-19. They're less likely to also have severe symptoms of it. So when vaccines are also always a risk-benefit ratio, as it is with any medication. You weigh the risk versus the benefits of getting it. When they weighed that risk-benefit ratio, the risk for people below age 30 was too much to justify based on the issues that one is having. But for individuals 50, 65, 70, their risk of getting COVID is way higher. Their risk of dying from COVID is way higher than getting a rare, very rare blood clot that they're still trying to figure out exactly what the basis of that is, even though there's a lot of chatter around it. I haven't seen any definitive data that says this is exactly what is going on. So, it's not unusual for people to have choices of vaccines, Eve. I mean, even for cervical cancer vaccine, you have the choice of getting Gardasil or Cervivax or Gardasil 9. So, most vaccines come with a choice that different manufacturers develop different types of vaccines for different things. So it's a good thing to have this ability to make that choice.
And I think in the UK, we will certainly move on to have choice over time. I just think where we are right now is that we're trying to achieve herd immunity as fast as possible. And therefore, it would slow the process down if individuals are there to cherry pick. And of course, if you think about it, we only have a certain amount of dose of any vaccine at any given time. And so if you go to a clinic and that's what's available for you, then it wouldn't be the wisest thing to refuse that just on the basis that it's not the one that you'd ideally want to choose.
Thank you. And hopefully, I'm aware we've gone over time a little bit, but I think we have some very salient questions that we need to address tonight. So if that's okay with you both, we'll crack on. This is a question that's been asked. Dr. Garrick, I'm not sure if the individual came through to you at any point on different platforms to ask this question, but it was a pressing issue. So I'm going to just ask you to address this. How does the vaccine affect people with autoimmune conditions such as systemic lupus or Sjogren's syndrome, which cause an overactive inflammatory response? I think I know Professor touched on the cytokine cascade earlier. So, but I'll ask you to address this, please, Dr. Garrick.
Thank you. So first thing I want to say here, and I think it's very important I say this, is that I'm not here to give specific medical advice about specific conditions and as it relates to the vaccine. I don't think it's appropriate for me to do that. I think your healthcare provider is much more aware of individual conditions and what that may involve, the factors that may involve, et cetera, and so on and so forth. So I think that's the first thing I want to address. And again, I can only speak on the UK context, so that's all I'll speak on here. Within the UK, for those with underlying immune conditions, so there's been a lot of chatter around this. And initially, a lot of people were told it's okay to go ahead and take the vaccine, irrespective of what your immune condition, underlying autoimmune disease is. And that was the advice that was given initially coming out of the UK. Certainly the British Medical Association and others thought that would be fine and that they should go on and do that. And I know of a lot of individuals with autoimmune diseases who have then gone on, taken the vaccine, and they seem to, okay, there's absolutely nothing that's affected them because the risk of not getting the vaccine was greater than actually the risk of taking the vaccine. So Professor Webley spoke about earlier about the risk ratio, the risk benefit ratio, that is, risk and benefit ratio. There's a benefit over and above the risk that will be presented of not taking the vaccine if you've got an underlying immune conditions. But again, I say based on your specific underlying condition, it's better for you to sit down and have that conversation with your healthcare provider and come to that decision. There is no data, and I could be incorrect here, Professor Webley, because I know you're more widely read than me. There's no data out there that says that these vaccines are not beneficial for people with autoimmune diseases and other underlying conditions. So I think it's okay from what I've seen to say there's a safety record of the vaccine for you to weigh up the risk and the benefits. The safety record of the vaccine shows that the benefits far outweigh the risk, and therefore the vaccines are beneficial for individuals with autoimmune conditions.
Yeah, totally agree. There is no data out there that suggests that people with autoimmune diseases are negatively impacted by the vaccines. Lots of people with autoimmune diseases have been getting all of the different types of vaccines that are out there. But I absolutely agree as well that this is a conversation you absolutely want to have with your physician. There are lots of different autoimmune diseases out there, you know, from rheumatoid arthritis to lupus. And people are in different stages of those diseases and different levels of control of those autoimmune diseases. You know, you might be on a therapy, you know, especially if you're on an exchange therapy, of a plasma exchange therapy or something like that, where your doctor might say, well, you shouldn't be getting that vaccine right now for other reasons. You don't want to get the vaccine, and in a short time you have to and then you have to go in for one of those exchange therapies immediately after that. That might affect the amount of circulating antibodies you actually have. So I think overall, that's something that you really want to have a conversation about. Thank
you. Are there any medical conditions or circumstances in which a vaccine may be contraindicated? I know you said go back to your GPPS, but just generally speaking, are there any contraindications and those who have a propensity for allergies and anaphylactoid type reaction, what should these persons do?
Sorry, is it me or does Eve sound?
Professor Webley.
Yeah. So I haven't thought up any conditions at this point that would negate getting the vaccine. Even people with allergies. Recently, some doctors actually, for patients who had an allergic response to the first dose of the vaccine, they actually went back and did, this process dosing where you cut down on the amount of it that they're getting and giving them injections with different amounts every 15 minutes. And they still were able to get the second dose. So there's a way to do that. There's a standard way to get vaccines to people who are allergic. So at this point in time, the only group that shouldn't get the vaccine are the groups that it wasn't tested on. People below a certain age group for different vaccines. For the Pfizer vaccine, people below the age of 16. For the Moderna, people below the age of 18. For the Oxford AstraZeneca, people below the age of 16. So those individuals, the vaccine hasn't yet been tested and approved on, and they shouldn't take that vaccine until that approval is in place. Otherwise, people who have had cancer, who are, whose immune system is still functional, can absolutely get the vaccine for protection.
I would agree with that.
Did you, sorry, Professor, sorry, I'm Dr. Garrett. Did you just say the vaccine was titrated over a period of time? Yeah,
there's a very specific way to do that, and I can send you something in the chat so that you can share that with your audience as well. But there's a very specific and rather standard way of actually doing that.
Okay, Dr. Garrett.
Yeah, I was just briefly going to say I concur on that in terms of there are no conditions at the moment that says it's a contraindicator to having the vaccine. The question that often comes up are those individuals who may have been on chemo or radiotherapy for cancer. And of course, as a result, their immune system has been depleted somewhat. And they ask the question, what's the point of taking a vaccine if the role of the vaccine is to help your immune system? Well, your immune system is already down. So what benefit is there? There is data out there at the moment to show that a cancer patient with a reduced immune function still gets some protection, some benefit from taking the vaccination. And of course, a lot of people have been arguing, what about plasma therapy instead? And what is interesting sometimes, and I don't mean to make light of this, but certainly it needs to be said, what is interesting sometimes, we often hear people, especially within these cohorts, saying that animal products in the vaccines, and yet you'd be willing to take plasma therapy when you're not willing to take a vaccine which has no animal product whatsoever. It's kind of interesting when you look at it like that. That to have plasma therapy sustainable or sustainably, it's a big undertaking, and that's not going to be the case. I will say that the vaccine is the most effective way of getting us out of this pandemic. One group in the UK which was given advice against to take or not to take the vaccine is pregnant women. In that it was said, if you are a pregnant woman, you work in an environment where the risk of being exposed to COVID-19 is significant, then you should take the vaccine. Otherwise, I don't think there's that push to vaccinate pregnant women in the UK as much as other groups.
Thank you. And on I have a question here about pregnancy, and it is, you've answered it, can pregnant women take the vaccines? Yes, depending. And is some kind of immunity conferred to the fetus? Does the fetus benefit in any way from this vaccination?
Absolutely. The data showed that IgG antibodies from mom got across the placenta and also got across through the breast milk. And so the babies were protected against COVID.
Thank you. Thank you for that. Thank you. This question is for both of you. And I like how it's going. You've been looking at both the UK and the US context. So I'm happy how this is going. In terms of therapeutics, there are more drugs that are used as adjuvants. We're hearing just the vaccine, but we have patients who are hospitalized It's not just vaccines. They're getting other medications. We have some trusts that are using cocktails of drugs to treat COVID-19. Can you tell a little bit about these? For example, I mean, you might not be in the acute setting, but if you know, please share. At what stage of the disease process would adjuvants, and it's up to the individual consultant, of course, and team looking after the patient, but at what stage do you suspect or think of the disease process are these drugs added? For example, we heard about the remdesivir, recently the anti-arthritic drug tocilizumab, dexamethasone, to help increase reduce mortality and improve outcome. Donald Trump, he advocated for hydroxychloroquine, which is another story. But at what stage do we think these drugs are added? And I have another, we're going to go back to diabetes in a minute. But at what stage would these drugs, you think, be added to treating patients in hospital?
So if I may start, because I think there's some very clear data on the steroid treatment, the dexamethasone treatment, and some data as well coming through on hydrocortisone. There's very clear data on that to talk about its benefit for patients who are actually hospitalized. So those with severe COVID disease, respiratory distress, and so on and so forth. So that drug seems to be beneficial within that context at preventing death and of course improving recovery, because what that drug does, it dampens the immune response, or the level of inflammation that has been produced via getting the infection. So that data is very clear on that and the benefits there of doing that in a clinical setting. I think you mentioned Donald Trump. I could be wrong in terms of what he was treated with when he was taken into hospital, but I think it was a combination. It was a cocktail of different drugs, which may have included dexamethasone. In terms of the others, hydroxychloroquine, and there was, I forgot her name now.
And tocilizumab, which was just added. Tocilizumab is the latest one, I think.
Yep. Mm-hmm. But back on the hydroxychloroquine, I know it was advocated by an African-American doctor. I've forgotten her name now. And as a result, a lot of people, Black people, especially within the UK, were saying, why is the government not giving us that? There's some conspiracy here because it's a Black doctor said it, therefore it must be good. And we know that initially, historically rather, to be an anti-malarial drug. And there are side effects from that. Particularly cardiac side effects. And the data wasn't there to convincingly show that that drug would be beneficial for people with COVID-19 infections. And so I personally, and I don't know if probably would agree with me, I personally would discount that one right now. The data is clear on dexamethasone, as I said. In terms of the others that you have stated, certainly within the UK setting, there isn't much to say that these are things that the UK or the NHS is going to take on. The remdesivir, we think we've got interferon beta, which a lot of people have been looking at recently, even though it prevented ventilation by, I think, up to 70 to 80%. There is still a big push at the moment to stick with the steroid hormone treatment within the UK setting. I don't know what it's like on your part. I call you Rev. I apologize.
It's the same. It's the same here. That it's really remarkable to me that people who have seen the data for vaccines discount the vaccines, yet the same people are screaming for hydrochloroquine, which has been shown clearly not to have any beneficial effect on treating COVID. Remdesivir has been shown to have minimal effect. And it's not clear if it's because it's used at a time when the patient is already so sick that you're not seeing as much effect as if the patient was infused earlier. But a lot of these drugs require hospitalization for them to be given because they're given intravenously, and so as a result of that, these drugs will only be given then. So people have been talking about hydrochloroquine and ivermectin. The clinical trials have just not borne these things out. Probably even more problematic are the people who are going around and giving advice on their bush stuff that they bought, especially my Jamaican friends who somehow have gotten a very great crop of Cerasee and Search My Heart and all of these other things that they're boiling together because this person said that it worked. And people have to be careful. Let's say that it is true that that thing worked for you. How do you know that it worked for your neighbor? That's why you do clinical trials. You do clinical trials to see if something has specifically worked. And when you're taking 10, 15 different things, you hear these people talk about, I was taking vitamin D, and then I was taking vitamin A, and I was taking this other thing, and then I took hydrochloroquine. How do you know which one of them worked? How do you know that it's not the type of slippers you were wearing that week that helped your disease? That's why you do clinical trials. You do clinical trials to, number one, determine that the thing is causing no harm, and number two, that it is beneficial to a wide group of people or to a select group of people that you can identify through these trial data. So we have to be careful of not going and spreading things. I see a lot of people through WhatsApp, giving these little videos. Here's what I did. I inhaled steam, and the steam was able to prevent me from getting sick with COVID. Well, you didn't have COVID in the first place if steam is what protected you. Because as I told you, the virus gets into the cells within 10 minutes of attaching to them. So in order for you to actually kill the virus in your airway, you'd have to kill all the cells that line your airway. Moreover, the virus is not just sitting at the lumen, it's actually going deeper into the airway that your steam can't access. And so again, people just need to stick with the medical evidence and not come up with your own concoctions of things that you think have worked for you that you now want to see widely used without trials.
Let me push the point, and the point is this. There is absolutely no drug on the market today that is more effective or shown to be more effective than the vaccine. And I think that needs to be very clear. So for all these individuals who are advocating for drug therapy, it isn't as good and as robust as the vaccine data. And as been said by Prof. Webley, oftentimes when these drugs come into play is when you're hospitalized already. So you have to think about that risk. Are you prepared to go to hospital just to get a drug treatment when you could get the vaccine that prevents you from becoming hospitalized in the first place? That's important. And you touch on the CERSI and you touch on all of that. But I want to touch on the issue of vitamins, because a lot of people seem to think that, if I take my vitamin supplements or if I have a vitamin-rich diet, it's going to protect me from COVID-19. That data is not standardized. There is no amount of vitamins that you can take into your system that's going to give you the level of immunity that the vaccine is able to confer. And I think that needs to be clear. Yes, vitamins do help to boost your immune system, but not to the same level that the vaccine is going to do. And I think that needs to be cleared up and it needs to be stated. The vaccine is the clearest way to protect you from becoming hospitalized from COVID-19.
And there is actually such a thing, Dr. Gary, as taking too many vitamins that will be deleterious to your system as well. Listen, people need to realize, people seem to think that the reason why you get infected with COVID is because something is wrong with your immune system. Nothing's wrong with your immune system. You've gotten infected with COVID because you're a human being, right? That's why you've gotten infected with COVID. You're a human being who came in contact with somebody who had the virus and it was transmitted to you. There is absolutely nothing you can do outside of wearing a mask, social distancing, to prevent yourself from getting infected. In fact, the vaccine doesn't prevent you from getting infected. People who have the vaccine still get infected. What the vaccine does, it protects you from having the pathology that comes with a COVID infection. You don't end up in the hospital, you don't end up dying. That's what the vaccine does. So people need to realize that. And this whole thought actually runs in some of the vaccine hesitancy, that if God has created me with a strong immune system, why should I have to take a vaccine? Because that strong immune system that God has created you with works in a very particular way, where you have an innate immune response going after the microbes that come into your system prior to you having a robust adaptive immune response. One comes before the other. COVID-19 can replicate and kill you within 7 days of you getting infected. People have died even quicker than that. The adaptive immune response that is best at protecting you from viruses, because it neutralizes the virus, doesn't get fully revved up until day 10 to 14. In other words, you could die from this viral infection prior to your adaptive immune system coming in properly. So as a result, you get the vaccine. The vaccine is not an alternative to your immune system. It works in conjunction with your immune system. People need to realize that. Nobody's saying that you should get this vaccine because your immune system is not working. In fact, if your immune system is not working, you probably won't get the vaccine because it just won't work, right? The vaccine is there to enhance, to boost, to turn on the immune system, to alert it to the fact that there is something dangerous here that you should be looking out for. And even a perfect immune system needs that. You need to know what to look out for, because it doesn't matter how well you have eaten. It doesn't matter if you're a vegan. It doesn't matter how long you've been a vegetarian. Your immune system, your adaptive immune system, is absolutely not going to come in any quicker than somebody who has been eating meat from day one, right? So we have to get these things straight. We have to get the immunobiology straight so that we're not fooling ourselves into thinking that somehow you're getting infected with COVID because there's something wrong with your immune system. Absolutely not. You're getting infected with this thing because it is a highly contagious virus that all it needs is your cells that have on it proteins that weren't made for the virus. The ACE2 receptors weren't made for the virus. They're there to help bring homeostasis to your body. But the virus has exploited them to be able to get it.
I want to push this point. Sorry, Heath, but I must push this point, and it's based on something you said, Prof, about the vaccine doesn't stop you from getting the virus. It stops you from being hospitalized. I know immediately some fit, healthy millennial is going to hear that and think, yes, that means I won't get it because you know what? The chances of me getting hospitalized from the virus is pretty much nil. That's what they're going to think. Let me make this point absolutely clear. If you don't want to take that protection for yourself, take that protection for those around you, especially older and more vulnerable family members, because this is also about protecting your fellow human beings. Okay, so whilst you may not end up in the hospital, you still have the ability to pass on the virus to somebody else. And that means that could be fatal for them. This vaccine, the data is coming through to show that it reduces transmission of the virus from one person to another. And so for that alone, think of people around you, think of others around you, and don't really think about it as a individual choice, but a choice that benefits the population as a whole. So I want you to keep that in perspective as well.
Thank you. And I'm glad you touched on the roles of, the issue, the concerns about vitamins and minerals as it relates to, their roles in somebody's.
Eve, I think there's something going on with your microphone. It's lower and there's some noise there, so I'm not sure if you want to reposition your microphone.
Okay. Is that any better?
No.
Sure. Any improvement?
I can hear you, but it's still pretty low.
Oh, right. I've turned the mic up, so hopefully that's a bit better. Can you both hear me?
I can, yeah.
Okay, good. Good. Right. And I'm just going to go back a little bit about on the issue of diabetes. We were talking about the adjuvants earlier. I'm just thinking the risk of steroid-induced diabetes, considering patients, are already, according to the reports and studies, are already at risk of diabetes, and COVID having this great affinity for diabetics. Could these adjuvants partly be accountable for some of the reported cases of diabetes that we're seeing?
Yeah, I mean, it's not clear to me what is going on there with what maybe is going to be called COVID-induced diabetes later on. But again, it shows you the physiological disruption that you can have from a virus that is so highly contagious and that has receptors in so many organs. We know, for example, that there are ACE2 receptors in the pancreas, right? So again, there's nothing that prevents the virus from directly affecting the organ that is responsible for the metabolism of glucose. And if you have a disruption in that, then it could absolutely present itself as transient, or I don't know if this is going to be a long-term diabetic condition. But again, what it underlines is the importance of just not getting infected in the first place and protecting yourself so you don't get that level of infection that leaves you in a hospital, because we know that people who are not hospitalized don't seem to be having this symptom and outcome. It's people who are sick enough to be hospitalized. A percentage of them are returning and presenting with these issues after that. So there is something about the severity of the disease that seems to lend itself to this type of pathology.
There is something coming out, especially in relation to this long COVID conversation, which we're still trying to get to grips with, in that it tends to exacerbate conditions that you already had. So for example, in the mental health setting, for those individuals who've developed or contracted the virus, if they had mental health issues prior to that, they seem to go on to experience far greater mental health issues. And it's still very much unclear what's going on there, but it does seem to suggest that COVID-19 tends to augment already established underlying conditions in a far greater way. And I think we are just at the beginning of this. We don't even know how long COVID is, even though we're calling it that. We don't know the extent to which it will reach, and so on and so forth, and why it impacts certain individuals more than it does others. It's a new thing that we're grappling with here, and we certainly don't have all the answers yet.
Thank you. I'm going to crack on to something that is it's a hot topic now, the Oxford AstraZeneca vaccine. We've seen the EU regulator, the EMA, that's the European Medicines Agency. There are reports of approximately 30 cases of blood clots in people who received the first dose of the vaccine, AstraZeneca vaccine, and 7 reported fatalities that, there's no causal link established, but, there are suspicions that they're related to the vaccine. We've had up to 13 EU countries suspending, some partially, some completely, suspending the vaccine until they've clarified what the issue really is. But this further lends the question, are these vaccines safe? I know we've spoken lengths earlier, but are they safe? And how does one put the risk into perspective for the wider public who is already spooked, and already spooked wider public who may be spooked by all of these negative reports? Negative reports about the AstraZeneca vaccine. Dr. Gary,
Sorry, Eve, your sound was going in and out, but I think I got the gist of what you said about the vaccine. So in terms of what you see going on in Europe, let me just, before we got to where we got to recently, let me just sort of clear up a few things. Initially, it wasn't even about blood clots. So let's just be clear on that. Initially, it was European government saying that, the vaccine was not tested in individuals above a certain age, over 60, and therefore it's not safe for their elderly population. They've not seen the evidence for that. So that was the first thing. Data coming through subsequently from the USA has shown that actually the vaccine is quite effective in the older age group. And so that cleared up that. The second thing that we saw coming out of Europe, I think, has to do with politics and the EU withdrawal agreement, Brexit. And the UK vaccination program, for example, has been going amazingly well compared to vaccine uptake in Europe. And as a result, we've seen several European politicians who have been, to use an adjective, salty about that, and decided to obviously say, the data on the vaccine is not seen in terms of its safety. And even though the European Medical Agency has suggested otherwise, we now have politicians saying to their population, actually, it is not the case. As a result, we've seen things that we've seen that there was a war between the EU and AstraZeneca about vaccine exports and how they're favoring the UK more than they're honoring their obligations to the European Union. So there was something coming out about they're going to block the export of vaccine components which were built in the EU to the UK. So that was all a bit of politicking taking place and going on. The French president, after going against the Oxford AstraZeneca vaccine, then subsequently went back to his population and said it's safe to take, and in fact made this big declaration that he himself is going to have it. So again, that just proves it was just politicking. What we've seen more recently, obviously, is the onset of these very rare form of blood clot, or this very rare form of blood clot, which has come through. Taking it to the UK context, around 29 million doses of the AstraZeneca vaccine has been given in the UK. Of that 29 million doses, it is said that around 79 individuals have been shown with this rare form of blood clot. And unfortunately, some of those individuals died. But to put this into perspective, it's only 4 in a million that gets a clot after taking the vaccine. And it's only 1 in a million that dies. It's a very rare event that occurs. And of course, it says that it's riskier. This is just what the statisticians are saying at the moment. It's riskier for you to go on a 250-mile journey car drive than it is to actually take the AstraZeneca vaccine. You're more likely to end up in a fatal situation going on that car ride than you are actually from the Oxford AstraZeneca vaccine. Unfortunately, what we see with this clot is that it was present, I think, in 3 individuals of those 79s under the age of 30. And the lower your age gets, the more you seem to be able or be at risk of getting this clot. And that's why the suggestion was made to not have it given to younger people. But I just wanted to put those numbers out there to put it into perspective. Currently, the data doesn't exist to say it's definitely the vaccine that causes this form of clot to take place. That data is not available. What we see here from the regulators in the UK is a risk-benefit calculation in suggesting that, okay, what is the best thing here to do? And in this case, the best thing to do is to give the younger population a different vaccine. It doesn't necessarily mean that the Oxford AstraZeneca vaccine is unsafe. And for those who've had their first dose of that vaccine, it doesn't mean you shouldn't go and get your second dose. There is no data from those, and I think over 5 million people now receive their second dose of this. There's no data from second dosage to say that you develop a clot after getting the second dose. So all the information that we're seeing now is based on information from the first dose only. And as I said, it's only about a 1 in a million chance of somebody dying from getting that particular vaccine. So at the moment, it's still, in my mind, from the data, a very safe vaccine. Of course, we need to take caution in terms of who we give it to, but it's still a very safe vaccine. I don't know if you'd agree on that, Professor.
Yeah, absolutely, Dr. Wilson. You know, whenever anybody has any sort of adverse reaction to any medication, it's a cause for concern. And with vaccines, operate on a system of safety. If a vaccine is not safe, you don't want to have it out there. And so that's why these are so extensively studied before they ever make it to market. With that said, in any clinical trial, no matter how many people you have, you're never going to be able to test every condition. And there could be something that gets activated. You know, people could have an underlying condition, and there is something that gets activated because you got the vaccine. I'm not ruling that out for what is going on with these clots. It's an unusual syndrome that goes counter to what we know about what is in the vaccine. However, it seems now the evidence is showing that the people who actually came down with these clots got them within hours to days after getting the vaccine. So it merits a closer look overall. And I could see people being fearful, but what you're seeing in full view is the process working. You know, the process that people fear, this process has worked beautifully, because what is happening is that you're seeing stuff, you're adjusting as you go along. You know, if you're driving a car for any period of time, you're going to have to adjust your steering. You can't just leave the car in one direction. So, you know, there's flexibility in the system to adjust and to say, hey, this group of people are exempt and should not be getting this vaccine because of what we're seeing happening. And that is totally fine. You know, when you see look at any drug that you see advertised on your TV, those little notes that they race through at the end, listen to all the people who should not get that drug. Listen to all the contraindications, right? A vaccine is similar, that, you know, you try to make it so that nobody suffers any ill effect from it, and so that it can do its work of protecting you. But a vaccine doesn't prevent you from getting something that you were already going to get, right? This vaccine doesn't protect you from having heart disease because it wasn't created for that purpose. This vaccine doesn't prevent you from getting clots that you were going to have already because it wasn't created for that purpose. It was created for one purpose, to induce your body to produce protective antibodies against COVID-19. So if there was something that was going to happen to you anyway, that thing is going to happen because this vaccine was designed to prevent you from having that. With that said, again, I agree with Dr. Wilson that we have to exercise caution. If there's something there to be learned and to be modified so that this vaccine can be even more safe, then that should be done. But at this point in time, I don't see anything that would say to me that you should stop vaccinating vulnerable population because of the data that we're seeing for these blood clots.
Let's briefly add to that, what is common or seems to be common among these patients or individuals who have sadly developed this clot is the fact that they had a low platelet count. That seemed to be a common theme among them. And we know platelets are involved in blood clotting and so on and so forth, but they had a low count. So that's a common theme among them. And in terms of what Dr. Webley was saying about those adverts you get and the small lines that I read out about the contraindicators and who this may be useful and not useful for, I think this is giving us enough information to say that maybe there are other things we need to be thinking about or considering when we recommend a particular vaccine formulation to individuals. And we're seeing this play out right in front of our eyes, as being said. And I think this is a good thing. It just shows science and good sort of medical sense in practice. And I don't think that's something we should be fearful about. And the other thing that's been said, and I want to emphasize this, it's been said by the regulators, is that if you get the Oxford vaccine, AstraZeneca vaccine, and you have side effects lasting for more than 4 days, don't just ignore that. Go and get it checked out. And these side effects can include headaches, tightness of your chest, difficulty breathing, bruising on your skin or at the site of the vaccine or of the injection. If you're seeing any of this and it's lasting for more than 4 days, don't ignore it. It may be a sign that something else is going on, and therefore you go and check it out. With that said, I must also point out that normally side effects from vaccines, they tend to clear up very quickly. Within about 48 hours, they're gone away. But if you do see anything longer than that, then do go and check it out with your healthcare providers just to make sure everything's okay.
We're winding down in a minute. Regarding all of this,
your sound is gone again, Eve.
I don't know what the problem is.
Check your microphone settings and see if you're using a webcam, for example. You might want to change the source of your microphone. See if that helps.
I'm not sure. Is that any better?
Yeah, we can hear you. There's still a little popping sound. I'm not sure where it came from, but yeah. Go ahead.
Right. I'm going to just say that given all that you said now, with the launch of the COVAX program, a lot of developing countries now gradually getting vaccines, and the AstraZeneca vaccine is by far the cheapest. And who knows, possibly the mainstay of the program.
Can't hear you.
Not hearing you. I think there's a positional thing there, Eve. When you were right where you were.
Can you hear me?
Yes.
Right. I was is that still hearing? Okay.
Yes.
Okay, good. With the launch of the COVAX program, and a lot of countries, developing countries receiving the vaccines, the AstraZeneca vaccine, which is by far the cheapest and possibly the mainstay of the vaccination program in these countries. There are these serious, what do these,
You cut out again.
there are serious problems. What would this mean for the developing countries on the COVAX program?
Sorry, not hearing you.
So I think she may be asking about COVAX.
Yeah, I think you're asking about COVAX.
COVAX,
Yeah.
what? Is that better? I don't know.
I hear you're asking about COVAX. Are you asking about countries actually getting, other countries getting the vaccine?
What would this mean for the issue of blood clots?
Oh, I see, with the AstraZeneca vaccine, because it's most likely the one that other countries are getting. Well, each country that gets the AstraZeneca vaccine will have to do the same monitoring that the UK and other places are doing. And any country, doesn't matter how small, who sets up a vaccination program, you can readily set up a system for reporting adverse events. And you track those adverse events and you look to see if you're having those issues overall. And that's what I would advise every country to do. I mean, I know that Jamaica has the AstraZeneca vaccine, although it was created in India. They have the same formulation of the vaccine. So each country needs to do that. But while you're on COVAX, I think the important thing is that as we think about the vaccines and their safety and everything, we think about bringing this pandemic to an end. It is important that every single country has access to some efficacious vaccine. Because if we don't, COVID-19 will continue to be with us. We can't vaccinate our way out of this disease unless we vaccinate the entire world. You see how quickly this disease spread from Wuhan to here and to the rest of the world. You can't leave any area of the world unvaccinated and be comfortable. It will just come right back to our doorsteps. And so it is really important that the wealthier countries actually look to now start getting doses to countries that are not as wealthy and couldn't actually purchase vaccines prior to them being approved, the way the United States and the UK and some of the EU countries have been able to do. It's really important now that we start pivoting and looking at how can we help countries, especially those that seem to be having a surge, vaccinate their people so that it doesn't turn around and come right back to us.
Yes, thank you. Are you hearing me?
Yes.
Oh God, I don't know what's going on. Right, we're going to wind down in a minute, but we've spoken extensively about the viruses and the vaccine. But just in terms of the future, we are talking in the UK, I don't know about America, about a COVID passport, a vaccination passport. So, at the moment. And I just want to get your opinion on this. It's nice for whatever reasons of not taking a vaccine. Should their civil liberties or movements be restricted as a result of this?
Well, the quick answer on that is no. I don't think you should do anything in terms of healthcare that restricts people's civil liberties. But at the same time, Dr. Webley just mentioned that this is a global problem. And when we all get out of it, that's when we're all going to get out of it. There's not one country that's going to get out of it before another country. And so for those of us who like to travel and just to get away, I think it's a sensible measure to take. And I'm sure this is going to happen, is a sensible measure to take to make sure that we don't transmit the virus around the world as readily as it was done recently. And a vaccine passport seems to be the safest way of doing that. In terms of just looking at it at a more domestic level, a lot of people in the UK, I don't know about the US, but a lot of people in the UK are just yearning to get back to normal life. They want to go to sporting venues, they want to go to theater venues, go to concerts and so on and so forth. And these kind of events are not worthwhile if the audience is not there to be involved in that participation and so on and so forth. And so certainly we see with the UK government, they're looking into measures where you can get going to a football game, for example, up to 10,000 individuals. The safest way to get things like this done is for individuals to have been certified as having been vaccinated. I don't think, with that said, I don't think it will get to a case where individuals are told that you can't have a life if you don't have a vaccine passport. I think it will only get to a case whereby certain countries will certainly be able to say to us, you can't get on a flight to us without showing that you've been vaccinated. Certain venues may refuse you admission because you've not shown as being vaccinated, but I don't think it will become a law in society per se, but ultimately it will become a good recommendation.
Yeah, I agree. I mean, right now, you could say there's a COVID negative test passport because lots of countries won't allow you in unless you can prove that you took a COVID-19 test within 72 hours and it's negative. And so it's not unusual to think that that could extend after a while to a COVID passport where you have to prove either that you're COVID negative or that you actually have the vaccine, have taken the vaccine. I mean, right now, most hospitals in the US will not allow you to work there as a healthcare professional if you don't get the flu shot because the flu is so contagious and you can infect patients. That's a vaccine passport. So, that there are schools that unless you have some medical exemptions, you're not able to enroll your child in school without them having been vaccinated. You have to show that vaccination record. That's a regular thing here. That's a vaccine passport to school. So I know that people get very anxious about this whole idea of a vaccine passport, but I don't think it's something that will be mandated. I think it's something that the people who don't have the vaccine will be outliers. They'll be the minority in the community because even with the huge anti-vax sentiment that we're experiencing, it's just because they're so loud, but they're not plentiful. We have vaccine hesitant people, but by and large, anti-vaxxers make up less than 5% of your population. Most people still vaccinate their children. So I think overall, we're going to have a situation where if the government does its job in reaching the people who are currently vaccine hesitant and get them vaccinated, and if we do our job as individuals, as communities, as church groups, as Dr. Wilson said earlier, and tell our people, explain to them the science and the safety of the vaccines, people will get it, and sooner or later you'll reach a stage where enough people are vaccinated that you have good herd immunity, and we would stop worrying so much about a vaccine passport because the virus itself will not be so prevalent in society. You'll hear of cases popping up every day now and then, and maybe you'll still hear of a few people dying here and there, but the virus won't be widespread, which means that the probability of you having it will be so very low, and the probability of you actually transmitting it to somebody who is vulnerable will also be low if you have it. So that danger will be significantly reduced.
I was trying to type in the chat. I can't type. I don't know what is going on with the system tonight. But you're hearing me clearly still, yes?
Yeah, I'm hearing you now. Yeah.
Right, we just have a couple of questions left. I haven't heard anything much about the flu this year. Over the last 12 months, for the first time in the US and in the UK. Not that people aren't having the flu, because I think I had a touch of something, but I have not heard a lot about the flu. What's going on with that? Professor Webley.
Yeah, I mean, it's really interesting, right? Turns out that the same system that leads to flu transmission is how COVID-19 is transmitted. People are washing their hands, they're staying away from large crowds, they're wearing masks. I think we've only had a single pediatric death in the US the whole season from the flu. I mean, this is unheard of. And so I don't know, maybe it's instructive about what needs to happen in flu season. Maybe we shouldn't be so quick to sell our stocks in mass because it might be a good way to significantly reducing the morbidity and mortality from stuff like the flu and other respiratory diseases. In fact, I'm good friends with a pediatric pulmonologist who I work with, and he was telling me that even asthma cases and allergy cases have significantly been reduced throughout the pandemic. So he says if it gets reduced anymore, he might be out of business. So there might be something to this mask wearing, even though people seem to hate it so much. It's very much protective.
That's really pretty. It's very obvious. It's very obvious. Thank you. And I have two questions left. And we've heard about people or persons behind the manufacturing of these vaccines or the development of these vaccines. And a very prominent name, is Dr. Kizzmekia Corbett, who played a super significant, she's a woman, significant role in identifying and developing the mRNA vaccine. And as a result, she's now a very popular and prominent figure at the forefront, emerging from behind the scenes of, in the life of the scientist. And this is a question to both of you, and we're going to keep it very brief because of time. But in the life of the scientist, is it usually this quiet until such events? What's your life been like in a nutshell as a scientist? Any one of you can take it first.
I don't know about you, Prof, but I think generally speaking, we are people who just get on with it. We're not looking for celebrity status per se or a big media role. We genuinely care about what we do. We genuinely care about the health of humankind and pushing the boundaries, getting new things out there, making things happen, and affecting people's lives in a positive way. We're very sort of concerned about things which are ethical as well, in that to make sure that what we do, it's not going to impact negatively on us and also those who we work for. So we're very careful about our reputations as well. And I don't think I can remember a time whereby scientists are being pushed so much into the limelight, the spotlight, or that people know what scientists do as much as they do right now. And this is very much a very new territory for us. In seeing the role that we have in society, but normally we just do that quietly behind the scenes, and it's just normally our lives getting that data, looking at that data, seeing what that data can mean for human health, improving on that, challenging things. And as much as we think that what the conspiracy theorists and the misinformers are doing right now is challenging, well, it's harder to get among us because we critique each other, we peer review each other just to make sure things are top notch and at the way that they're supposed to be. And I suppose the best way I can describe it is that it's the pursuit of the new. It's the pursuit of the better. That's what we spend our lives doing, the pursuit of the new, the pursuit of the better. And I think that's a bold endeavor. I think all of this in many ways is a distraction.
Yeah, couldn't have said that better. Scientists are people who are typically awkward when you turn the spotlight on. By the very nature of the way we dig for information, it means that we're not out there looking for any sort of spotlight at all. I look at Dr. Corbett, who I follow on Twitter, and for 6 years, she was in that research lab at the NIH, researching spike proteins and coronaviruses. Looking at the structure of it, looking at every gene and the way it folds, and everything you can think about it. And she was ready when this pandemic hit because they were studying MERS, and we're just getting ready with Moderna to start clinical trial on MERS, and then this thing hit, and she had everything in place. Got the plasmids ready, was able to get the product sent, and did the clinical trials. Did the mouse studies, the preclinical trials on this, and I look at her as a young, she's very young, a young Black woman in science, and I think to myself, I hope enough young Black girls are looking on who can be inspired to be in science, and you don't have to be a medical doctor to contribute to medicine. That research behind the scenes is an important thing. But I think a lot of scientists have been thrust into the limelight, and some of us have made missteps because we're not used to that over this process. But I think what it has taught me is that it's not just important for me to do the research. It's important for me to figure out how to communicate that effectively, not just to my colleagues, which, when you think about it, when you write a paper, it gets peer reviewed by your colleagues. It's literally almost like it's written just for your colleagues. We need to now think about, how do I communicate science to the populace? How do I communicate science to the person on the street so they can understand what it is that their tax dollars are funding if you get federal funding, and why it is that I spend all that time in the research lab trying to develop something. And I think this is a great moment for that. It's a great teaching moment about how science happens, how hypothesis-driven research works, and the importance of that to a whole community. And it also suggests patience. You can be working for 50 years on something and nothing happens. And then all of a sudden one day, there's a disease on the other side of the world, and all of that work that you did now come to fruition in a very short time. Can't hear you.
Nothing at all?
Yeah, hearing you now. Stay right there. Yeah.
Right, I was saying my oldest niece, she's 22 years old, and she's a qualified biochemical scientist. The pandemic has unmasked and has exposed a lot of injustices within our healthcare system and society in general. And we do talk about forward-facing professions and jobs. We don't talk a lot about the degree of representation that we have at the very top. And considering your positions and the work in this field, what advice would you give to budding young scientists who are aspiring to be one day Professor Wilmore Webley, a Dr. Garrick Wilson, a Kismikia, or even an Anthony Fortune? What advice? And we have about 4 minutes.
I would say stay in school, learn your sciences, do your math, understand biology. Don't allow anybody to tell you that because of your gender or your race, you can't learn this or you can't learn that. There's nothing true about that. Find good mentors. Find people who are supportive of your dreams, and talk about it all the time. Get excited about it and show people that you're interested in it. Find at the appropriate time, whether it's in college or in high school, find somebody who is willing to allow you to come to where they do research, their lab facility, and for you to shadow them or observe or do a summer internship. Look for opportunities for scholarships that fund these things, for research type scholarships. Don't be afraid to work hard and to dedicate yourself to something. And those dreams will be realized. Especially if you're first generation, you're underrepresented, you might not even know what the process is of going about getting a PhD or a doctorate degree in something. But there's always somebody who's willing to tell you. You just have to be true to who you are and follow that dream to the very end.
That's good. One of the things I've been very active in doing is ensuring that when it comes to summertime, I make sure that I take young Black boys, young Black girls, provide them with work experience, proper internship within the research environment. And that can be anything from something simple for them to work on, but also just to be in that environment where they see scientists at work on a daily basis, understand that process and how it might work. So that's just one aspect of it. I've also just been very active in engaging community leaders, and this could be church leaders, for example, to open up their big buildings where they have space such that people who do science can come there and actively showcase their work, just to inspire young minds to say, this is what I've been getting up to, this is what it's telling me, and this is what I think it means. And they begin to see that process as a result where somebody like them can just come right to where they are and begin to showcase that to them. And I'd also go a bit further and say, which is something that I've been doing recently, is lobbying some of those influential leaders, especially within Black and ethnic minority communities, who always talk about these things, to put their money where their mouth is. So, what, give me some money whereby I can invite and take some of these individuals, register them for a science-based conference so that they can just come and their minds just be expanded. Wow, just to see all these individuals from different parts of the world working on some amazing things, and also be able to be in conversation with them in places like that, the right ones. You can run into some Nobel Prize winners as well, people who have gotten to the top of their games, and they can inspire you all the more. So it's just about being active and being very proactive in things like this. And you mentioned earlier, I think we're having a conversation, you talk about the curriculum in terms of what's being taught in schools here. Just the way it is right now, I don't think it's designed to inspire. And I think there are those of us who are within the scientific field right now who has a responsibility to go back to school levels, way back in the earlier parts of it, and say, let me give a seminar. Let me give a presentation. Let me run a practical, whatever it is that I need to do. Let me engage in that way to actually inspire you from a very early age that this is a worthwhile adventure that you should go on.
Nice discussion. We still have loads of questions, but I think we've hit some very key ones tonight. I want to thank you for sharing on the seminar tonight. Those who listened in, you heard both from a UK perspective and a US perspective, the viruses, or the variants. Can you hear? I'm not sure what is going on. I'm not sure what is going on. I can't type. I'm not sure what is going on. But can you close the program? Can one of you just close it for me? I'm not sure why I can't hear, but can one of you close? Can one of you close for me?
We can hear you now. Stay right where you are. Don't move.
I just want to say thanks to those who are listening. Thanks for your comments and the questions that were sent in beforehand. But I want to say a big thanks to Professor Webley and Dr. Garrick for sharing on St. Lab tonight and taking the time out just to educate us and to clarify the misconceptions and some of the myths that are out there. And I hope this benefits those who've not had the vaccine yet. And this will inspire you to go and get protected. Not just yourself, but those around you within your immediate community. Guys, thanks for sharing. And I do hope that at some point in time, we can do this again. I do realize in your portfolios that you do a lot around cancers. So chances are we will meet again.
Thank you for having me, Eve. Thank you for what you continue to do.
Mm-hmm. Likewise, Eve, and thank you again, Professor Webley. Great to share another platform with you.
Thank you, Dr. Wilson. It's been great doing this with you again.